Okay, now let's come back and let's go back to this window, right? So this one is just a very simple calculate the kinetic energy problem, right? So
Are we finishing this whole unit tonight?
probably not, but we'll just get as far as we can with energy, and then I'll just pick up the rest on Wednesday. But I think we'll probably get to a certain point and have to stop anyways. So what was I about to say? This is the kinetic energy problem, right? So actually, I want everyone to take like 3 minutes, right? Do this problem. It's pretty quick. Come up with an answer and put it in the chat. As you're doing that problem, look at these equations, right? You got one that's disappearing. Sorry. 1, 2, 3. The problem is saying to calculate the what? Which type of energy? Potential, kinetic, or mechanical?
Kinetic,
So which equation would you use?
first one.
First one, right? So that's your starting point. Come back in 3 minutes, and I want to see answers in the chat. All right, let me see some answers in the chat. Same one for 15-ish, 14.96. Good. Anybody else? Anybody else? Put answers in the chat. It don't matter if it's right or wrong. All right. Let me know if you can see this. Can you see the board?
No,
Say it again.
I only see a white hand.
It's better. You see the board? Yeah. Good. We're good. All right. Okay. So I wanted to do it, right? So we're just calculating the kinetic energy, right? So it's just multiple steps. First thing, figure out which energy we talking about, right? We talk about kinetic energy, so we have to use the first equation like we have first, right? So kinetic energy, remember, is related to our motion, right? Motion, which means we need to have some type of velocity, right? So that's how we know this need this one. So now we have a mass, we have a velocity that was given to us in our equation, right? So it was given. We got a mass and a velocity, right? Our unknown is our kinetic energy, right?
I can't see nothing.
You see now?
No, I just see a white hand.
Are you look? Wait, where are you looking at? Do you see my screen?
Oh, I can see it now, but it's at the top.
She was looking at the presentation.
Like the computer is only on the KE.
She had to open your.
No, look at my picture, my video.
No, I'm saying I see the whiteboard, but the screen is only on the KE.
This part, you see this?
No, the bottom part. You got to push the laptop. Yeah, that.
Okay.
Now we can see it.
So now I got my assumptions, right? What am I assuming? Just assuming that the object is moving. Assuming that the object is moving, the system is conserved, that's fine, right? So now we can find kinetic energy. Now, this was the physics part. This, just math. I plug in the equations, the numbers is equations. I square this 2.4, I get 5.76, then I multiply that by this here. And I just multiply by 1/2, or you could divide by 2, to where you get 14.976, or about 15. Physics, math. Make sure you just set up the physics right, then the math, you literally just put in a calculator. And if we look here, look, same answer. So let's do this, but now for potential energy. Same deal. Come back in 3 minutes. So 7:25.
What are we doing?
Same thing, but calculate the potential energy. So now instead of kinetic energy, we want to find the potential energy. So which equation will we use? 1, 2, or 3?
I can't see the screen, but I'm sure it's 2.
Okay, 2. Yes, 2 is right. So once you figure out your answer, go ahead and put it on in the chat.
I can't see the formula and I don't know it on it's not on a practice sheet.
Are you looking at the screen?
This in your
Maybe I need to take it off the pen.
No,
I'm
not my presentation. Is the presentation still on?
your presentation.
Yeah, so
Yeah.
just look at the
I am, I don't see it.
Kinetic energy have.
How about now?
Yeah, I see it now.
Put your answers in the chat.
Hold on, I'm about to put it in there. I'm about to put it in there right now.
I'm trying to calculate number 7.
Hold on, I think I might have calculated something wrong. Give me 1 second. I'm about to just change one number.
Okay.
Give me 1 second. Okay, give me 1 second. I did calculate something wrong. I put in the wrong number, but I do have the other number. Hold on. Okay.
Mass times gravity times height. Wait, so I get the force, which already calculated from the gravity, already takes into account gravity, and then I do it again for the potential.
What is it? Mass times gravity. Mass times gravity is what? What force is that? Weight, and then the height is a what?
Oh, okay, my bad. I was thinking about it wrong. I was thinking about doing that and then multiplying it by gravity the second time. My bad. That's right.
So I'm seeing the same answers. Do we see the board now? See the board?
Mm-hmm.
All right. So now when we do this one, right? We're looking at a different energy quality. So come here. Now we're looking at potential energy, right? So now we're looking at the mass times the gravity times the height. Let's think about it. We store something on the shelf, right? The force that we're storing is a person's weight, right? Mass times gravity. And we're storing that for a distance, which is this height. So it's a height above ground. So that's how we get the, just like how we do work, right? So the work to be able to store something above ground. So now that we know that, right? That's the physics. What were we given? We were given a mass and a height. What is our unknown? The potential energy. But what do we have to assume? We have to assume that we're on Earth, that gravity is equal to 9.8, which we know is true, right? Now we have everything we need to solve this equation. Physics, math. All you gotta do is plug this in the calculator, multiply it, you get 295.568 or joules, or you've rounded about 2.96 joules. More concerned with you understanding the physics and getting to this point. You get to this point, we're good. Same answer. Now this one right here, as we just calculated, right? This one right here is more conceptual, right? So mechanical energy of an object, which one is it? You got the equation next to you to the right as well. Remember we talked about mechanical energy?
E.
Energy of an object due to its motion or position. You said B. You said B?
Yeah.
Minus potential energy minus kinetic and object energy. So if you say that, then it looks like this, right?
So then it would be D.
You're saying B?
D.
D?
Like, yeah, A, B, C, D.
D. So kinetic plus the potential energy of object at any instant during its motion. Yes. Yes. So just like our equation, the mechanical energy is the kinetic plus the potential energy at any instant during its motion. At any instant during its motion, right? So let's look at a certain arrow, right? So when we're looking at these right here, this looks like a roller coaster, right? Going up, or you can say sled and whatever, but it's the same type of example, right? We want to find the total kinetic energy of the objects at positions A, B, and C, right? So what is mechanical energy again? The energy of an object due to its motion or position, or in mathematical forms, the mechanical energy is equal to the kinetic energy plus the potential energy. So if we want to find the kinetic energy at position A, what do we have to do? If we want to find the mechanical energy at position A,
Add
how can we find that? Add them up. So then we just add what?
3,000 plus 7, which is 10.
And what?
10
10,000.
ME.
10,000 joules. All right, so we got 10,000 joules for the first one. Do the second one real quick.
It's 9,000 newtons.
Get the unit. 9,000 what?
Newtons.
Joules.
Oh,
So joules is for energy. You got the number right, the magnitude, but just make sure we got the units right. 9,000 joules. Do the third one real quick.
100,000.
Good, 100,000 joules. I'll just put 100K.
And then the next one is 80,000 joules.
Good. Now the math is easy, right? But what are you doing each time? Conceptually, right? You're adding what? Potential and kinetic energy. So that's really what we're doing. Yes, the math was easy, but each time to find the mechanical energy, we're adding both the potential and kinetic energy within that system. So now right here, right? What we want to do, same thing, take 3 minutes, come back at 7:36 and put in the chat. We want to calculate the total mechanical energy of the object moving at 2.4 meters per second in position at 5.8 meters above the ground. Once you got your answer, put it in the chat.
I put mine in the chat.
All right, let me see what we got. Three 311. Okay. Can we see the board? Can we see that?
Yeah, but you didn't get 311.
It's 310.5. Same thing. Not the same thing, but if you route it, it's around 311. Hold on, but yeah, about the same thing. So if you got 311, you're fine. Now, how did I get this? Where am I at? Hold on. Clear this. So logically, right? We just talked about what mechanical energy is, right? Mechanical energy is a kinetic energy and a potential energy. So really, they gave me a mass, a velocity, and a height. I need to find the mechanical energy, which I know is kinetic and potential. So I have everything to find my kinetic energy. I just need to assume that my potential energy is equal to gravity, right? Sorry, my gravity is equal to 9.8. Now I have everything to solve my potential energy. And basically, we just solve for both, which we just do, right? Now, if you can see, right, I color coded it on purpose. The red is the kinetic and the blue is the potential. Why? Because it's the same thing we did over here. These are the same exact numbers. So essentially what you should see is all you already did was find the energy from each individual one. So really you could have actually went from here and just jumped right to here and then got the answer. And I would have been fine with that because we just calculated up in the earlier ones. Now that right there will really be understanding physics. This would be physics. If you did this, you really will understand physics. Because this is really understanding, oh, the concept of mechanical energy is that we're just taking the potential and kinetic and adding together. Oh, which you just calculated the previous two problems. So let's just jump right here and just add them together. I just added this because I know math could be the tricky part. This is also part of physics. Physics. So we are now, I didn't want to leave any steps missing so that you'd be able to follow it. But really, you could have went from here to here and it'd been fine. But the rest of that problem was just to show you that if you calculate it individually, you can just add them up at the very end. So I hope we got a good sense of how mechanical energy works. Any questions?
No, not for this.
See, 311. All right. I think, yes, this right here is going to be our last one of the night. All right. So with this one, right? With this one, right, let's take our time and we want to really basically determine in each scenario, right, if the kinetic energy, potential energy, or mechanical energy increase, decrease, or remain the same, right? So I got the definitions up top, right, for which one each one represents, right? And now we want to just see if it goes up, down, or remains the same. So what I'm going to do for this one is I'm going to just do in red, I'm going to circle it based off of what we conclude, right? And we see how we go towards the end. So for each situation, right? So a marble begins at an elevated position at the top of an incline ruler and rolls down to the bottom of the ruler. So the marble starts at the top and then it rolls down to the bottom of the ruler. Let's start with kinetic energy. Does the kinetic energy increase, decrease, or remain the same?
Increase?
Increase. Starts to move, right? Now, the potential energy, does it increase, decrease, or remain the same?
It remains the same.
Why do you say remain the same?
Because I'm thinking about the marble sitting at the top, and that's the only time it has potential energy.
So it's at the top, it's elevated, right?
Yeah,
And it goes which way?
down.
Down. So what changes about it?
It goes down.
What does that mean?
Oh, it decreases.
What decreases?
The potential energy?
Because what decreases?
The potential energy.
Yes, but what causes the potential energy to decrease inside of that? Look at the equation. What changed?
I don't know. The
Yes,
marble
you're right.
moving?
The marble is moving, right? But what also is changing? It's on a elevated position and it rolls to the what?
Down.
To the where?
Ground.
The bottom of the ruler, right? At ground, right? So first it's at the top of the ruler, then it moves to the
Bottom.
bottom. So what changed?
The position?
Yes, or the H word.
Essential. I don't know. I have no idea.
It's right
Somebody else
there.
help.
It's right there. It's on the equation. What's that H stand for?
Oh, the height.
Height. So the height changes. Yes. So now it decreases. Now, what would we say about its mechanical energy? Does it increase, decrease, or stay the same? So mechanical is what again?
Potential plus kinetic. So I guess we would look at it. What's a positive plus a negative?
Or say, and what do you see? One goes up and the other goes.
Right. One goes up, one goes down. So positive plus a negative is, I don't know. I
Is
want
what?
to say it's positive. No, it's a negative. Positive plus a negative is a negative.
It depends.
Yeah, that's what I'm saying. Somebody else can answer that.
So think about it.
If the positive and negative are the same, then it's
Equal. So we could say this one, the total mechanical energy within the system. This one, we could say it stays the same.
Why?
Think about it. Bank account example, right? I have two accounts, right? I have $100 in total. I have it sitting though in between my checking and my bank and my checking and my savings. I have $100 in total. So in both of them, in both accounts, I have $100. Now, I start off with my money in my savings account. Then I want to go buy something that's $50. So if I want to buy something at $50 and it's in my savings account and I have to move it to my checkings, what do?
Take it out?
I take it out. So how much do I take out if I want to buy something that's worth $50 and I have 100?
Just 50.
50, right? So I take out 50 and I put it in where?
The other bank.
The other account, right? So now with my checkers account, did my balance increase or decrease?
Just decrease.
In my checking account, the one that I'm moving into.
It increase.
Now the balance that I took it from, the account that I took it from, my savings account, did it increase or decrease?
It decrease.
Now before I buy anything, right? Did my
Mhm.
total amount of money that I have increase or decrease? Or stay the same?
I don't even know. Like, I guess it stayed the same.
Yes, no, you just answered it. Stay the same. I have $100 between the two counts. All I did was just move one to the other account. But the amount of money I still have is still $100. That's what we're saying with this example right here. When we started at the top, we have just potential energy. But then when we move the marble, it goes and it rolls down to where now we have more kinetic energy and less potential energy. But the total amount of energy, mechanical energy, which is the sum of both of them, is still the same. Even though it just changed because of the motion. Does that make sense?
A little bit. It's just the equals part, but I guess we can move on. So maybe I'll see it in another one.
Yeah, let's try. A marble rolling down a level table when it hits a note card and slides to a stop. So what do we say about kinetic energy? It's rolling along its level table and then it hits a note card. Decreases, right? Because what changes? Velocity, right? Is the velocity increasing or decreasing? Decreasing. So the kinetic energy is going to decrease because the velocity is decreasing. The mass is still the same, consistent, right? Now, with this potential energy, right? It's rolling along a level table, right? What does that mean, a level table? How does the table look? Does it look like this? Or does it look like this? Or does it look like this? Which one does it look like if the table is level?
It would look like the first or third.
Level. The table is level. What does level mean?
The middle.
So it'd be the middle one, right? So if it's the middle one, right? Do I change my height at all? No. So if I don't change my height, will my potential energy change? It'll do what? Or, because I could be above ground, it'll do what? Instead of changing, it'll just do what? Instead of changing, stay the same. There we go. Now, between my total mechanical energy was my potential and kinetic energy, right? What did we say about my kinetic energy? Did it increase or decrease? Decrease. My potential energy, did it increase, decrease, or stay the same? Stay the same. So for my mechanical energy is also kinetic and potential, right? So if my potential energy stayed the same and my kinetic energy decreased, if I add those together, what changed about my mechanical energy? Did it increase, decrease, or stayed the same? Decrease. Good.
So it's the potential and kinetic are the same, or if one of them is decreasing and the other one is same, that means the entire mechanical energy.
Correct.
And the opposite is true if one of them is shifting and the other one is increasing, the entire energy is increasing.
Correct. Let's try this next one, right? So we got a cart. It's pulled from the bottom of an incline to the top of an incline at constant speed, right? So it's at the bottom of the incline. And then it's pulled to the top. First of all, it's at the bottom and it's pulled. So it's moving, right? Is it moving? Is the cart moving?
The cart is pulled up the cart.
Now, with its speed, right?
At a constant.
Constant speed. So is it increasing or decreasing? So it's the same. So kinetic energy is the same only because the speed is constant. It's not changing. So the same energy is present, right? But it's not changing. There's no change in velocity. So now with this, right? It's being pulled though from the bottom to the top of the incline. So
the potential is increased. As it's pulled to the bottom.
from the bottom to the
From the bottom to the top, not top to bottom, my bad. So it's increasing.
so energy increasing. Good. So now with that, right? This is just the same case we were just talking about, Sean. The total mechanical energy, right? Does it increase, decrease, or stay the same? Increasing, because we're going from bottom of an incline to a top of the incline. So now we have it increasing. All right, we got 4 more. Actually, let's do it like that. You see how this is going? So I did the first 3, right? All right. Let's do, who else is online? All right, let's do 2 more real quick. The physics student runs up a staircase at a constant speed. So if it runs up a staircase at a constant speed, what's happening with kinetic energy?
It's staying the same.
Why is it staying the same? Why is it staying the same?
Because the constant speed.
Constant speed, right? Now the student runs up the staircase.
Potential energy is
Why is the potential energy increasing?
because you're going up.
Because you're going up. So what does that mean for my overall system?
Mechanical energy is increasing over time.
Increasing over time. Good. All right, one more. Actually, so let's go take 2 seconds. So what I'm gonna do is I'm gonna put y'all in breakout rooms, and I want y'all to answer the problem that I gave y'all. I'm gonna just do 2 real quick, and one just end with this. Hold on real quick. Pretty much I got everybody that's in person. in one group, and then everybody that's online in one group. So everybody in person, I want you to do E. Everybody online, I want you to do F, and then we'll do G together to wrap up, and then we'll be out of here tonight. Take a picture of the question before you leave out. Now I'm opening the rooms to join. Come back in, I'll close them. Come back in like 5 minutes. 5 minutes, yeah.
From the rest. Forces applied to a loose sphere.
Professor, I was trying to join a breakout room, but it's not working. No one was in there.
Oh no, it's fine. It's just you got other people just didn't show up. But go back to the breakout room. You got question F,
Okay.
and just come up with an answer if they join in and just work together. And then
No one was in there.
that's what I'm saying. Everybody's still in the main room. So like literally take like come back at 8. So go at 8, come back at 8, and work on this problem in step F for a second. All right, let's go with group E first. I'm gonna mute myself. Someone come off mute and explain the answer so everyone else can hear.
For letter E, for a force is applied to a root beer mug to accelerate it from rest across a level countertop. For the kinetic energy, I said that the kinetic energy was rising, and that is because it is going from at rest to moving across the countertop, which means that if velocity changed, then it increased. For the potential energy, I put that it is going to stay the same because at no point does the countertop experience elevation or de-elevation. And then for the mechanical energy, I put that for the total system, it is increasing over time.
Thank you for that, Sean. Anybody agree, disagree? Thinking that was a pretty good explanation. All right, Courtney's group. Do you have an answer for F?
We didn't do breakout rooms, but I kept trying to go to it, but I didn't see anybody in it. So I don't know what they got as a group. I know what I got.
What'd you get?
So for the first one, because a pendulum is released at rest and it swings to its lowest, I put that the energy was decreasing for kinetic energy. And for potential energy, I put it was decreasing because it's going from being elevated to going to the bottom to the lowest. And then for the mechanical energy, I put honestly I put decreased. I don't know if that's right, but I put decrease.
Okay. So I'll leave those two and we'll come back and check them, right? So let's do this last one all together. So a car skids from a high speed to a stopping position, right, along a level highway. So a guy goes from a high speed and then goes to a stop. How does the kinetic energy change? Does it increase, decrease, or stay the same?
I put increase.
The kinetic energy decrease.
Increase or decrease? Which one we going with? I got a disagreement.
I put increase, but I guess it's saying it's going
Right.
from a high speed, so that means it's decreasing.
So what's decreasing?
The kinetic energy is decreasing.
Because what else is decreasing?
The velocity.
The velocity. What'd you say? The speed, the velocity, yes. So therefore the kinetic energy is decreasing. Now, is the height increasing at all?
No. So it
No,
stays the same.
so it stays the same because we're at a level highway. Now, because the kinetic energy decreases, the potential energy remains the same. How does the mechanical energy change? Increase, decrease, or stay the same?
I put stay the same. I don't know if that's right.
Why'd you put stay the same?
I don't even have a reason. It just sounded like the right answer to me.
Okay. Anybody agree, disagree?
Oh, because it's stopping. It's just in the same position as stopping. That's why I put it in. It's on a level highway.
Okay. So now let's think about it. What does mechanical energy represent?
It's the potential and the kinetic mixed together. So it'll be a negative plus an equal sign. So I guess I was right. It'll be decreased.
So you're saying it's decreased now?
Yeah.
Okay. Now, before I start breaking stuff down, let's just see how we did. So for the first one, we got increase, decrease, and remains the same. We got that. Then we got decrease, remains the same, decrease, good. Then we got remains the same, increase, increase, good. Remains the same, increase, increase, good. Now let's get to that E, increase, remains the same, increases. Now for F, we got increases, decreases, remains the same. We got decrease, decrease, and decrease. Okay, so we'll come back to that one. Then for G, we got decrease, remains the same, decreases. Good. So let's come back and look at F, right? So a pendulum blob is bob is released from rest from an elevator position and swings to its lowest point. So its velocity does what when we release it? Does it stay the same or does it change?
It's going down, so it increases.
So we let go of it, right? It experiences what? What force? Force gravity, right? So it experiences acceleration due to gravity. So because it feels acceleration, so now we're going to have a change of velocity. So it goes from going at rest to now it's not at rest anymore. So now it's what? It's moving, right? So now instead of having a velocity of 0, we have a velocity that's non-zero. And that keeps happening, right? It'll keep changing because it's going back and forth. So what does that do when the velocity is changing and actually increasing? What is that going to do for the kinetic energy? Increase, decrease, or stay the same? Increase. Good. Now, when we look at the potential energy, right? With the potential energy, we go from its height position to now it goes to the bottom. So when it was at this top, right, that was above ground, above 0, and then it went to the bottom. Now we're at 0. So how did the height change? Did it increase or decrease? The height decreased. So if the height decreased, how does that affect the potential energy? It went down, right? Decrease. So now we have that same thing, right? We got a pendulum. The kinetic energy increases, but the potential energy decreases. Now, how does that reflect my total mechanical energy? Does it increase, decrease, or does it stay the same? The same, right? And how do we know that that makes sense? When you do a pendulum, right? Like this one right here, where is it at? It's over there, right? Is that it? You get the little ball things, right? When you drop them back and forth and hold it, they keep swinging on forever and ever and ever, right? Technically, but they keep going. You'll see that the energy is conserved in that little system, right? Because as the kinetic energy switches, now you get to potential energy. Then after potential energy switches, you get back to kinetic energy. So you just back and forth, right? You increase and then you decrease in one time. So then we see that it remains the same in the total system. So that's starting to touch a little bit about the conservation of energy. But this one was highly conceptual to really get you understanding it. Now, next time when we come back on Wednesday, we'll really dive into how work and energy play along with each other, and then we'll get to our end goal. And then I'll even introduce us a little bit to unit 7 to kind of wrap us up. And then on Monday, I'll make sure we have enough to like really wrap up everything. I'll make sure we have everything we need. So these next 2 classes I'll be here in person, pretty much from 5:30 to 8:30 to kind of do what we just did today. Today I'm letting you out like a little bit early, but like really gonna use these last 2 classes to really just get through the material. If anything, we'll just make sure we'll get through all the material, and then we'll just go from there. Due dates are updated. I'm grading y'all stuff as you submit it, so just submit it as much as you can. And yeah, same thing with the labs. Labs up to lab 10. Make sure you complete all of them. Those are due after the last day of class, which would be the 4th. So you got some time with labs. So I think I made the labs at 6. I think I made labs due to 6. So you got some time.
Okay, because I have a question. I was about to say I was going to turn in my labs. I only got up to 4, but I saw that there was 10.
Yeah, so just take your time and just finish them.
Okay.
Any other questions? We're good? All right. See y'all on Wednesday.
See you. Bye. Have a good night. Thanks.
Good night.